Hello everyone, I Professor Bhavik Kumar M. Kataria welcomes you into the video series of Information and Network Security. Today we are going to discuss Unit number 10, Web Security Threats and Approaches, SSL Architecture and Protocol, Transport Layer Security and HTTPS and SSH. Out of this, we have already discussed some basic fundamentals related to web security in computer network subject, as well as we have discussed transport layer security and HTTPS and SSH during the video series of computer network. So today we are going to discuss SSL architecture and protocol of SSL. Let's see what we have discussed before today. So we have discussed unit number 5, cryptographic hash function and application of cryptographic hash function. So at that time we have started from the simple table. So whatever the key is used behind the simple table structure, we have reduced it by using the hash table. And after using the hash table, we have seen the various types of hash function to decide the key position by the hash value. So at that time we have discussed some of the hash functions like mid square method, folding method. So various types of hash function we discussed at that time. Same thing during the use of various types of hash function. We have discussed the issue of collision, and we have also discussed the collision resolution techniques like separate chaining and open addressing. Same thing in terms of open addressing, there is a linear probing, quadratic probing and double hashing. And then after we have discussed the cipher block chaining and SHA secure hash algorithm. We have discussed unit number 6 about the message authentication code, MAC requirements, MAC security, MAC based hash function and MAC based block ciphers. Then after we have discussed the digital signature. In terms of digital signature, we have mainly used it for the authentication and non-repudiation. But one limitation of digital signature was the confidentiality and message integrity. So at that time we have achieved the issue of message integrity by using the digital signature scheme DSS, which is produce the message integrity, as well as we have achieved the confidentiality by using the encryption and hash function. So that are the overcomes of limitation of digital signature. We have discussed the NIST and DS algorithm. So in that case we have discussed the various types of scheme, like first mainly we have discussed the two approach of digital signature, that was DSS approach and RSA approach. And in terms of NIST DS algorithm, we have discussed two algorithms. First algorithm was Elgamal scheme and second algorithm was the Schnorr algorithm. So we have discussed two main NIST digital signature algorithm. Then after we have discussed unit number 8, key management and distribution. In this thing we have discussed mainly three topics: symmetric key distribution using symmetric encryption, symmetric key distribution using asymmetric encryption, and distribution of public keys. So in terms of first portion, symmetric key distribution using symmetric encryption, there is a use of secret key, as well as in terms of symmetric key distribution using asymmetric encryption, there is a use of public key and private key, and mainly it is done by the simple secret key as well as secret key with the confidentiality and authentication. Whereas in terms of public key distribution, we have discussed public announcement, public available directory, public key authority and public key certificate. Then after we have discussed X.509 certificates and public key infrastructure. In terms of public key infrastructure, we have discussed KDC, Knowledge Distribution Center. Because of in terms of key distribution, suppose there is n devices are located into the network, or n parties are there for the communication. So there is a requirement of n into n minus 1 by 2 keys for generation of this type of multiple keys is very much difficult. So that's why we have used the knowledge distribution center at that time. Whereas in terms of last session, that was about the remote user authentication using symmetric and asymmetric encryption and Kerberos. So if you are still remain to watch the video of Kerberos, so you can click on I button at top right corner and you can watch the previous video. So let's start today's session about the SSL architecture and protocol. So first thing, what is the need of SSL? It means secure socket layer, which is known as a SSL. So need of SSL is for the data transfer between web browser and web server. So whenever web browser is communicating with the web server, suppose there is any browser into the client side, which is going to be communicate with the server. So while communicating with the server's browser and client's web browser, so at that time for the data transfer between these two entities, SSL is responsible. So that is the need of secure socket layer. Now let's see the working of secure socket layer. So basically it is working with the connection and session. So in terms of connection is a transport to provide services. It means whatever the data transfer is going on in between the web server and the web browser, so this entire data transfer can be take place by using the connection. And another one is a session. So session is a association between client and server. So whatever the association between server and client, this is done through the one session. Get it? So that is the roles and responsibilities of connection and session. Another thing, whenever we want to implement a session, so session can be implemented through the handshake protocol. So if you are still remember that in terms of basic computer network, whenever we have discussed the transport layer unit in terms of computer network, so at that time we have discussed the three-way handshaking. Get it? So whatever the fundamentals of three-way handshaking can be applicable here into the handshake protocol. Now let's see SSL protocol stack. So basically it is carrying the SSL record protocol, handshake protocol, change cyberspec protocol and alert protocol. So this entire protocol stack is based on this 4 basic protocols, and all the protocols are working in sequence like layered approach. In terms of computer network, we have discussed OSI model and TCP/IP model. So these are the layered approach. So all are working into the sequence or their separate tasks. Same thing is here in terms of secure socket layer. These are the protocol stack of secure socket layer, and all these 4 protocols are working into the sequence one by one. So these are the all protocols into the sequence. First one is a SSL record protocol, then after SSL handshake protocol, SSL change cyberspec protocol, and then after SSL alert protocol. So where actually SSL record protocol is located. So SSL record protocol is located above the TCP and below the HTTP. So below the HTTP and above the TCP, SSL record protocol is located, and then after here the remaining protocols, SSL handshake, SSL change cyberspec, and SSL alert. So let's start our first protocol, SSL record protocol. So to discuss this protocol, there are basically, as we have discussed, working in session and connection. So these are the session state parameters and these are the connection state parameters. So let's see, from the first there is a session identifier. So session identifier is an arbitrary byte sequence chosen by the server to identify an active or reassemble session state. Whereas next one is a peer certificate. It is a one type of X.509 certificate. We have already discussed earlier what are the usefulness of X.509 certificates. Then after compression method, this field is a optional field. It's not a compulsory field. Whenever we are using the compression techniques, then and then there is need to mention the whatever the method we have used during the compression of data. If we are not making the compression of data, so there is no need to mention any method. Suppose we are going to use, then and then we have to mention. Then after there is a cyberspec. It will specify the bulk data encryption algorithm. Look like various number of encryption algorithm we have discussed, like MD5 and SHA. So this type of algorithm can be used for the encryption purpose. So whatever the algorithm we are going to use, that we have to mention here. Then after master secret is a one type of secret key. Is a one type of secret key which is 48 byte sequence key. And another thing that is reassemble, that is a one type of flag, and it is indicating the it is indicating the session. So whenever we are generating a session, so session can be initiate or not, that can be decided by the flag. Next there is a connection state parameters. So if you will look here, so there is a server and client random. So it means it is a one type of byte sequence, that is a byte sequence, and that can be chosen by the server and client for the connection establishment. So to establish the connection, there is a number of byte sequence can be chosen by the server and client. Another thing, that is server write MAC address and client write MAC secret. So these are the secret keys for the MAC. MAC is a message authentication code, and for the message authentication there is need to generate one secret key. So that key is generated by the server and this key is generated by the client. So both are generating a secret key for the message authentication. Here there is again server write key and client write key. So here again that is one type of secret key. So here that secret key can be write by the server and another secret key can be write by the client. Then after initialization vector, so initialization vector is working like to maintain the each number of keys. Like here secret key generated by the server for the MAC address, here secret key generated by the client, same thing here secret key generated by the server and client. So to maintain the whole number of keys, there is a initialization vector which is responsible to maintain the whole number of keys, and last one there is a sequence number. So these are the various parameters working into the SSL record protocol. so which is useful to keep the record of all the informations. And after keeping the records of all the informations, there is need to starting from the first phase, that is SSL handshake protocol. So let's see the next step, SSL after the SSL record protocol. But before going to the forward, let's see how SSL record protocol is keeping the records. So first there is the application data, so that is the entire data. So out of this entire data, first step, that is a fragmentation. In terms of entire data, we are generating the number of fragments, like fragment number 1, fragment number 2 and fragment number 3 and so on. That is depends on the size of data, we can generate a number of fragment. Another thing, that is a compression. If there is a data compression is required, again there is a large size of if there is a large size of fragment, so there is need to compress the data, as we have discussed in that is the optional feed for the compression method. Suppose we are doing the compression, so there is need to mention the algorithm or technique used during the compression. Then after add message authentication code. So after compressing the data, here we are adding the MSE. And after adding the MSE, we will do the encryption of both this thing, and that is our actual encrypted data. And at last, SSL record header can be added after the original data. So there are the two portions, that is header, and this one is original data. Get it? So if you will look at what should be available into the header, so into the header there are various types of fields are available. Like first field, that is a content type, which type of content is going to be stored. Another thing, major version and minor version. So major version will be the probably 3 and minor version probably 0. It means which of the number of versions are generated for this protocol. Another thing, that is a compressed length. Suppose data can be compressed, so let's see actual size of data is up to this. So this number of bits are compressed. Get it? So whatever the number of length is going to be compressed, that we have to mention here. And here there is a compressed data and plain text. Suppose data is not going to be compressed, so plain text is available. And then after the message authentication code. So let's see, the next one is a handshake protocol. So in terms of handshake protocol, there is 3 fields: type, length and content. So type is the field of the 1 byte, length is filled with the 3 byte and content with the greater than equal to 0 bytes. So maybe suppose there is a content is not present, so there is a 0 bytes of, or there is a content is available, so it would be the greater than 0 bytes, depends on size of the content. So type is a higher layer protocol. So whenever after the handshake protocol, it will be hand over to the upper layer, look like layered architecture. Then after, in terms of length, it is carrying the length of the message, how much long data packet is there. And in terms of content, there is a parameters associated with the message. Let's see how handshake protocol is working. It is working basically into the 4 phase. Into the first phase, client is sending a client hello message and server is responding with the server hello message. So that is the testing purpose. Look like whenever we are going to communicate with the another guy, so we are just saying hi, good morning, hi, hello. So these are the testing purpose. Line is actually connected or not. So that is phase number 1. If line is connected, so server will check the authenticity. Whenever we will call to some unknown person, so unknown person will ask our name, from where we are calling, from which organization we are calling. So whenever there is unknown user, so we are asking these details. Same thing, server will ask for the certificate, server key exchange, certificate request, and after requesting this thing, server will completely done the server hello. So after getting the so many requests, client is responsible to produce everything, like someone asking our name, our organization, our city. So we are responsible to provide these details for the further communication. So client will produce the certificate, certificate key exchange, and certificate verify. Get it? So after verifying this detail, communication can be take place, and into the phase 4, client will send a change cyberspec and finish the data communication. Same thing, server will change the cyberspec and finish the communication. So how handshake protocol is working during this phase number 1, 2, 3 and 4. And after the completion the task of handshake protocol, next protocol, that is the change cyberspec protocol. So what is the main role of change cyberspec protocol is converting pending state to the convert state. Up to the working of previous protocol, handshake protocol, actually data is forwarded to the next higher level. So till this moment data state is pending. So now it will change the state from pending state to convert state. So that is the responsibility of change cyberspec protocol, and it is using the 1 byte and volume 1. Now after completion of from the changing state to convert state, there is a responsibility of alert protocol. So alert protocol is working with the two fields, one is level and second one is alert. Both fields are carrying 1 byte size. And in terms of level, there is a warning and fatal error. So which type of warnings are there? So warnings are look like unexpected message, bad record make. It means message authentication code is with the bad records. Decompression failure, like whenever we are compressing the data from the sending side, so destination side always it will require the decompression of data. So maybe if suppose some bits are corrupted during the communication, so it will generate issues during the decompression. Whenever we are doing the decompression, so we are not able to get the original data. Then after handshake failure, it means during the entire communication, connection cannot be established properly, or it should not be a reliable connection. Like suppose in terms of computer network, we have discussed three-way handshaking. Suppose we are calling to our friend, so till the completion of our communications, whenever we want to convey our message, so till the convey of message, connection should take place. If due to the any type of error, connection goes to disconnect, so we cannot say that this type of connections are reliable. So that is the example of handshake failure. Illegal parameters, like due to the some illegal parameters we are using the connection, like some of the fraud calls we are getting. Get it? Some of the companies are calling simultaneously, so we are going to blacklist those number of callers, or just we are going to add the block list. So that is the illegal parameters used. So these are the warnings, and these are the alert messages like fatal error. So let's see what are the alert messages. First, close notify. It means in case of emergency, they are sending the notification for the close and send the notice about the close the connection. And look like no certificate. Whenever server is asking to the client to produce the number of certificates, and certificates are not produced by the client, so there is a no certificate. Bad certificate. This certificate is not proper. Like whenever a client is producing the certificate should not be readable, certificate should be corrupted, so it is a bad certificate. Unsupported certificate, it means certificate is available but which is not supported for this particular connection. Certificate revoked, it means certificate revoked and certificate expired. It means like whenever we are using the PUC, so it is there is need to renew it by the 6 month or a 1 year, depends on the particular allotment of certificate. So after the expiry date of certificate, we have to always we have to register it again, and we have to expand the validity. So that is certificate expire and certificate revoked. It means somewhere certificate can be not feasible with the actual available content. So that is everything about the alert protocol. So that was how there is used of security during the SSL, secure socket layer. So till we have discussed the main points of the security related discussion, and it was our last session of information and network security. Here we are completing the theory portion of information and network security. So thanks for watching the video series of INS.